Alrighty, there we go. So, I would definitely recommend you guys to at least, look over your textbook pages, or you can, obviously do the handouts also. The handouts are, remember I had mentioned, they come from a different textbook, so the formulas or their notation might look a little bit different, but essentially your calculations are the same. But this is kind of where we get into, like I was talking about, those confidence intervals, coming up with your point estimate for a population. So it's a very basic formula here. You can see that right over here, the p hat is equal to x divided by n, x of course being the number of individuals, or whatever they're looking at in your sample, and then n would of course be the sample size, what the total number of um, sample that was studied, and then how many people were in favor of or against, depending on whatever the question might be. So definitely use your textbook for your formulas and stuff. And one of the most important formulas is going to be right here, where we try to find the confidence interval, and I'm actually trying to find that. Right, here we go. So how do you construct your own confidence interval? And since it's an interval, you have a lower bound and an upper bound. So this formula definitely will come in handy when it comes to these calculations. And what I have also done, and let me see if I can bring that up, in your D2L course shell under MyLab statistics, you guys might have already seen this. I've actually included a formula sheet. So the formula sheet has all the formulas, from the first chapter to the last chapter that we discussed. So you have this formula sheet, which, kind of looks like this. So it's the, different formulas you have in there, like I said, from all the different chapters that we cover. So you can kind of look at this. If you need, go ahead.
Oh, sorry. Oh, I was just gonna ask, are we able to use that on like the final?
Yes.
Bring that to the, okay.
Yeah, definitely. And I have actually created one, and I don't know, I thought I had posted this, but maybe I switched it out when I got access to that one. So this one that I have created has all these tables that you need, so for your binomial distribution, the normal distribution and stuff like that. So I've included, and all of this is from your textbook, but I've just kind of put it all together in one place. And then, like I said, I have, copied over all these different formulas from your textbook itself. So I will actually see, I thought I had shared this on the D2L course shell, but I couldn't find it the other day when I was looking for it. So I'll go ahead and make a new post about this one. And because this is a PDF file, so you guys can save it on your, desktop, computer or laptop, whatever you are using, and you can use that on your exam also. But I really like this one because, all the tables are there together in one place, so you don't have to go through your textbook pages to try and find it, because we will be using that normal distribution table here again for this chapter. So you guys have already used it, in the past, but we'll be revisiting these. So for now, let me see if it will let me send you a copy of this through the chat so you guys can have it, and then I'll post it for the rest of your classmates on D2L. So hopefully you will see that file coming through on chat with Zoom. And of course, you will find a lot of similarities with this formula sheet that you already have under MyLab statistics, but you can use both of them, either one of them, whichever one you're comfortable with. Alrighty, guys, so let's get into our first example for today. And this one, as you can see, is from section 9.1 homework, and it's problem number 9, or you can look at this number on the left-hand side, the 9.1.27. Oh, Riley, it didn't come through. Okay, I will try sending it again. And you might have to allow it a little bit of time to download if you're having unstable connection. But if it doesn't come through, I will definitely post it on D2L. So, this is one of the more common type of examples you see in these, confidence interval sections. So, they're telling us we have a random sample of, and I'll try to make this a little bit bigger. We have a random sample of 1,011 adults in a certain large country, and they were asked, do you pretty much think televisions are a necessity or a luxury you could do without? And out of these 1,011 adults, 526 said that they think TVs are a luxury they could do without. And then they're asking us, all of these questions based on that. So you will see even in your homework problem, they are actually giving you access to the standard normal distribution table. So you do have access to the table. Not all the examples have them, but some of them will. So you can see this is for all the negative z-scores. And then the page 2 is going to be your table with all the positive z-scores. So you do have access to them, but I like to keep the table handy because, like I said, not all examples are going to give you the tables. So the first part they're asking us is to calculate a point estimate for the population proportion of the adults who believe that televisions are a luxury they could do without. So this formula, and what I have actually done, because I try to use as much technology as I can to make my life easier. So I've actually put the formulas here. So this one here is for your point estimate. And you can see this is literally taking x divided by n. Your x value, oops, wrong one, is going to be those 500, there we go. The 526 people who said, they think it's a luxury they can do without. And then remember, your total random sample is for 1,011. So those are the numbers that we are going to be putting in here. So for the x value, we can have 526, and then the n value is the total of 1,011. So your point estimate is basically a calculation of x divided by n. So you can just, like I said, either use a calculator or you can use Google Sheets or Excel to help you out. So that's going to be the 526 divided by 1,011. And you will see I've put an equal to sign next to it. So that way, Excel will do the calculation for us. And you can see this division is coming out to be 0.5202769. Actually, I need to stay here. And then here is where they're telling you how they want this answer rounded. So you will see they're telling us to round this to 3 decimal places. So when you round it to 3 decimal places, what do you think this number will come out to be?
0.52.
Yeah, because you're just going to 3 decimal places. So you can see that will be the 0.520. And then since you have a 2 after that, it will just round to, 0.520 because that 2 does not make a difference. And I will actually leave that 0 in my answer. So 0.520. Leave it at 3 decimal places, and that looks good. Alrighty, so let's say okay on that. Now this one here, and you're gonna have to do this by default when you're working with these types of questions. So they are saying verify that the requirements for constructing a confidence interval about P are satisfied. So what happens in this case is when they talk about, verifying the requirements, you actually have to check to see, and let me see if I can write this down here for you. So you actually have to see when you multiply n times the p hat, remember the p hat is your point estimate that we just calculated, and of course is our total number of adults who were surveyed, and then you multiply this with 1 minus p hat. So you have to multiply these three values, and if the number comes out to be greater than or equal to 10, then we are good to go with the confidence interval. So that's one of the things we have to check. The other one is we have to see if our sample size of n is less than or equal to 5% of the total population. So remember, capital N is supposed to be the actual population. So if we were talking about adults in this certain large country, then that capital N means it's all the adults in that country. The little n, of course, is those 1,011 out of the entire population that we are surveying. So a lot of times we actually assume that this is going to be correct because we don't know what country this is. We don't know what their population is. So we really cannot do a calculation per se to see, do we have at least 5% of the country's population in this survey? So usually we say, yes, we are meeting this need. So all you really need to do is check for this little calculation if your answer comes out to be greater than or equal to 10 or not. So, again, I'm just going to use our little Excel sheet over here or the Google sheet to, help us out with this. So let me just clear this out. Alrighty, and we'll go back here. So to check for this, again, I've put the formula right here. So our n value is going to be the 1,011, and we already have that. Our p hat is the, just again, use the rounded number. So that's the 0.520 that we rounded it to 3 decimal places. And then for the 1 minus p hat, again, I'm just going to put that in parentheses. So I will do 1 minus the 0.520. So you can see we have our three numbers, n times p hat times 1 minus p hat. And when you do the calculation, of course, you will see that is a number greater than or equal to 10. So we're definitely meeting that requirement. And like I said, we just assume that this requirement is being fulfilled. So this guy is already greater than equal to 10. So he's good to go. We're making the assumption this one is good to go. So that means for our example over here, we can say, okay, the sample is stated to be a simple random sample, because you can see those are the first couple words in your statement. It says it's a random sample. So they're telling us, we cannot say it's assumed because they are specifically telling us it is a random sample of 1,011. So that is going to be is stated to be. And then this is the value of, and this is the formula we used, n times p hat times 1 minus p hat. And this calculation came out to be, and let's see, what was that number we had? 252.3456. Do we have a rounding instruction here? Yeah, they're telling us 3 decimal places again. So 3 decimal places would put this at, of course, you've got the 252, and then what happens after the decimal? What will we have? So when you round it to 3 decimal places, what should we get for this?
0.3.
No, remember you have to go out to 3 decimal places. So that means you have to be at 5, and then having a 6 after that. What does that mean for your rounding? Yeah, very nice. So it will actually become 346 because the 6 makes the 5 go up. So just make sure after the decimal point, you have 3 digits, okay? So 252.346. All right, and then they're telling us which is, of course, this is greater than or equal to 10 because that's one of our requirements. It has to be greater than equal to 10. And the sample size, I believe that should be sample size, yeah. And the sample size, I would say, can be assumed to be less than or equal to 5%, of the population size, because honestly, like I said, we don't know what country this is. We don't know what their population is. So the best thing we can do here is just assume that this 1,011 people that we are surveying is going to be less than or equal to 5% of the total country's population. So that part, we definitely, make an assumption on that. So we will need to check our answer. Okay, that looks good. Now we are actually getting into constructing that 95% confidence interval. Now, when we're talking about 95% confidence interval, we're not really talking about the proportion, or we're not really talking about the probability that 95% of the people are in favor or against television. What we are saying is that as researchers, as statisticians, we are confident that this is going to be true, or this is not going to be true. So in this case, they are saying construct and interpret a 95% confidence interval for the population proportion of adults who believe that the televisions are a luxury they could do without. So we have to show that, based on these results, as researchers, we have that confidence level that these people are saying, what they are saying is true. And here is where we get into some interesting calculations. So you can see this is a 95% confidence interval, which means when you have to select your alpha value, your alpha is actually going to be 100% or 1, because we write these in decimals. So your confidence, your alpha value is going to be 1 minus, and then since they said 95%, that's going to be 0.95. So your alpha value is 1 minus whatever that confidence interval percentage is. And remember, you're doing these in decimals, so it's 1 minus 0.95. So that's going to be our alpha value. We always calculate alpha divided by 2, and you will see that what I'm actually building up to is this formula right here for our confidence interval. So right now, all we have done is calculated the alpha. Now we need to do alpha divided by 2. So for that, just next to it, I know my alpha is 0.05. I'll take that number divided by 2. So again, I'm using the Google Sheets to do the calculations for me. And you can see if we're going to be dividing 0.05 by 2, it's going to end up becoming 0.025. So this is basically alpha divided by 2 that we have over here. So now we need to calculate the z-score for this 0.025. And that's where those tables are going to come into play that I was talking about. So we have our standard deviation, standard normal distribution table over here. So let me see, we are looking at a z-score for 0.025. So what you actually have to do is in the body of the table, you have to find either the number equal to 0.025 or anything closer to it. So you can see we are 0.025. And again, I'm going to try and, so you can see we're kind of in that 0.02 range over here. We just have to find 0.025. Right there, 0.025. So that's your probability or your percentage, and then you have to see which z-score it corresponds to. So you can see on the row side of things, it is at negative 1.96. And then on the column above, it is at 0.06. So you are actually looking at a z value of 0.025. And the z-score for that comes out to be negative 1.96. So you've got negative 1.9 from here. And then the second decimal place 0.06 from there. So it comes out to be negative 1.96. However, we're not really dealing with these as normal distribution curves. So we actually ignored the negative sign. I just wanted to show you, where the z-score comes from. And if you actually continue down this table over on the next page, you will see this little table at the bottom on the left-hand side, the confidence interval critical values table. And let me clear some of this out. Let me see. So you can see right here at the 95% confidence interval, which is what we are trying to calculate, they're telling you what your critical value for the z-score of alpha over 2 is going to be. And this corresponds to 1.96. And that's the exact number that we got by using the table. The only difference is you are dropping the negative sign that the table gives you. So you can use the standard normal distribution table. You can obviously use this little confidence interval critical values table over here, because these are the most commonly used confidence intervals. Now, if you're looking at a confidence interval that is not mentioned over here, then you will need to go into the table to find it. So anyway, so you have your 1.96 from here, and that's what we are going to need for our z-score. So that's the number, we can enter over here, 1.96. Okay, so we already have our p hat. We calculated that as the very first part of this problem. You have your z sub alpha over 2, which is the 1.96 we just came up with. And I'm actually just going to write it over here. You already have all of these numbers. You have the p hat. Of course, we can calculate the 1 minus p hat, the n value, and then we need to do a square root. So again, use a calculator if you're comfortable with a handheld calculator, or again, you can use this to do your calculation. So let's calculate the lower bound first, and then we'll calculate the upper bound. So remember, the lower bound is going to be the minus formula with the minus sign, and the upper bound is going to be the formula with the plus sign. So you need to do, again, equal to, our p hat value is the 0.52 from here. So you can either use the cell, or you can type in 0.52 over here. Then from that, we are subtracting our z value, which came out to be 1.96. So that's going to be this cell with 1.96. And then we multiply. But guys, everything is underneath a square root. So you will use the square root formula, which is the SQRT. And you see it opens up parentheses. And then this is where we will need to type in this entire calculation. So first thing we have is p hat. So again, that's 0.52 multiplied. And in parentheses, I am going to do the 1 minus p hat again. So that's again your 0.52, that same cell. Close parentheses. And then we are dividing by the n value, which came out to be 1,000. You know what? I did not put it in a cell, but I'm going to put it in there. So I need to put my 1,011 here. So you can see, you can either do this by using cells, or like I said, if you want to do these with numbers, you can do that also. 0.52 for the p hat minus our z-score of 1.96 multiplied by, and then we do the square root. So that's the square root, open parentheses. You do the p hat again, so that's 0.52 multiplied by, in parentheses, 1 minus 0.52 again. Close that parentheses, divide by your n value of 1,011, close parentheses, and that takes care of your lower bound. And you will see those calculations come out to be exactly the same. So you can do it with a cell. You can do it by using the numbers. Now, remember, the only difference between the lower bound and the upper bound is that plus and minus sign. So all I'm literally doing is copying the formula over. And I am going to change this from a minus sign to a plus sign and make sure all my cells look good. So that one did not translate too well. So that should be, actually that should be E1. And that happened because I did not use those dollar symbols. I should have used the dollar symbols for my Z-score. It was 15. This should be E1 again. Oops. And then this guy will be 3. Oh, well, looks like I have not fixed it properly, but I'm just going to use it here with the numbers. Change that minus to a plus sign, and that will calculate your upper bound. There we go. So just your lower bound and your upper bound, and that gives you your confidence interval. So as we come back to our example over here, we are saying, let's see, there is a 95% probability. This is not a probability. This is a confidence interval. So you're actually going with option B. We are 95% confident the proportion of adults in the country who believe that televisions are a luxury they could do without is between, and this is going to be your probability value. So what did we come up with? And looks like we are rounding all of these to 3 decimal places again. So rounding to 3 decimal places, this guy will come out to be 0. And then you have 4892. So what will that 3 decimal place look like? So 0.4892 to 3 decimal places. Riley, what do you think that will round up to?
.489.
Yeah, 0.489, because the 2 will not make our number go up. And then Jacob, what do you think about the upper bound? .5507.
Wouldn't it be 0.551?
Yeah, very nice. The 7 makes that 0 go up, so 0.551. So those are going to be our bounds, 489 and 551. So 0.489 and 0.551. So we're basically saying that we are 95% confident that the proportion of adults in this country who believe that televisions are a luxury that they can live without is going to be between almost 48.9% to 55.1%. So remember, the confidence level is different from the probability. And then the last part here is basically saying, is it possible that a supermajority, which would be more than 60% of the adults in the country, believe that the television is a luxury they could do without? Is it likely? So look at your confidence interval over here. We are going from 0.489 to 0.551. Now 60% falls outside of that range, right? Because we're stopping right at basically 55.1%. So we can say it is likely, not possible, possible, but not likely. So more than likely, you would pick the last option, possible, but not likely, because like I said, your 60% is falling outside of this range. And that's the reason why, yes, it could be possible, but more than likely, it's not going to happen, is what we're saying. So it's possible, but not likely that the supermajority of adults in the country believe that television is a luxury they could do without, because the 95% confidence interval does not contain your 0.6, which is the 60%. And again, remember percentages, we always put them in decimal form. That's why we're writing that 60% as 0.6. And now they want to know, using the results from part C, which is where we calculated the confidence interval, construct a 95% confidence interval for the proportion of adults who believe that the television is a necessity. So remember, this confidence interval is for the people who said we could do without the television. Now they want to know what would be the confidence interval for those adults who think that TV is a necessity. So this is actually very simple, because this is where you just take the numbers we calculated and you will do, 1 minus, because now you're finding the other half. So you would do 1 minus 0.489 for this guy. And this one would be 1 minus 0.551. So this will help us come up with the other confidence interval. So, of course, put the smaller number first. So 0.449 will be the lower bound. And then for the upper bound, I think we had 0.511. Check your answer. So, and the reason I picked this example, as you can see, it has so many steps involved in it that I wanted you to be able to see that, how we break down this process. And once you actually understand that, then a lot of the other examples will become easier, because they'll follow the same format. They'll just keep changing the survey question. Instead of television, they may use something else, but the general setup is going to be the same. So questions on this example here, guys? Anything coming to mind? Okay, another example I kind of wanted to look at was number 12, which is the 9.1.41. And let's take a look at this guy. So they're telling us in a poll, 69% of the people answered yes to the question, are you in favor of the death penalty for a person convicted of murder? So 69% of the people said yes. They're saying the margin of error in the poll was 5%, and the estimate was made with 96% confidence. So they want to know, so we're actually working backwards. They want to know how many people were surveyed. So how many people were asked this question? Now, remember, when we talk about margin of error, we're basically saying there can be some calculation errors that can happen. It can be some survey errors that can happen. Maybe you didn't do a good job of selecting, a random sample. And remember, we had talked about how important it is to get a good mix of people when you're selecting your sample. So we always include the margin of error calculation with our confidence interval. And that's also something you guys will be working on as you go through these examples. So let's take a look at this one over here. We are saying what was the minimum number of people surveyed. So we need to come up with that. But before we can do that, let's take a look at what information we have here. So I believe, have a chart for this also. Okay, there we go, 9 point. Okay, so our p hat, what do you think, just by reading this example here, do we get an idea of what that point estimate or the population proportion should be, looking at these numbers here? We know our confidence interval level is 96%, margin of error is 5%. 69% of the people answered yes to this question. So anything that you would imagine could be that p hat value. The E, capital E, stands for margin of error. Of course, the Z sub alpha over 2. So it's really the p hat we need to identify so that we can calculate how many people were surveyed, which is going to be that n value. Crystal?
Well, I know the 69% of that, but I don't know how it gets like the number, the actual number.
Yeah, so 69% is going to be that p hat value.
Oh, okay.
Yeah.
I was thinking of it being like trying to find the actual number of.
Yeah, because
That's
we
not what
don't
we're doing.
know, right? We don't know how many people were surveyed, but if you go back to the example we just got done talking about, remember how we calculated that point estimate by taking the X value divided by the N value? So we knew 526 said TV is a luxury they can do without, and 1011 were the total people surveyed. So what they're actually giving you is that 0.52 value, which is 69% in our case. So they're giving you this value, and we have to work backwards to find the n, basically what we're doing.
So like the p hat value is 0.69.
Very good. Yeah.
Okay.
Let me see if it will. There we go. Back to our example here. So very good. For our example, the p hat value is 0.69. Remember they told us the margin of error is 5%. So the E value or the error is going to be again in decimal. So that's going to be 0.05. Now let's take a look at calculating that alpha value again. So very similar to what we did last time. Our alpha value is going to be 1 minus, and remember the confidence interval was 0.96. because they're telling us it's a 96% confidence. So again, 1 minus 0.96 to calculate the alpha. And then remember for alpha divided by 2, you're basically taking the 0.04, dividing it by 2. So this is our alpha divided by 2. All right, so let's take a look at what the z-score will be corresponding to this alpha over 2 of 0.02. We'll go back to our table again. Now, this is kind of what I was talking about. You know, you can see there's no 96% confidence interval over here. So you do not have the z-score value, but we know it's got to be somewhere between these two numbers. So what you need to do is we will go back to our table over here and look for 0.02 in our table. 0.02. And remember the 0.02 is coming from this number over here, the alpha divided by 2. So 0.02, do we have anything like that? 0.02. I guess it's going to be between these two numbers, right? The 0.02. So basically you are looking for 0.0200. So can you tell me which one of these numbers is going to be closer to the number we are looking for? Is it going to be the 197, which is closer to our 200, or the 202?
202.
202, yeah, because this is only 2 units away from the number we are looking for, and this guy is 3 units away. So this one is closer. So that's the z-score we are going for. So that's going to be the negative 2.05 when you combine, the horizontal and the vertical columns together. And again, remember, drop the negative sign. So we're really not interested in the negative sign. So that's going to be 2.05 as our z-score for this guy.
And we use the 0.02. Well, so will we always use the 0.02 because it's divided by 2, or
this number over here?
Yeah. Oh, yeah, the 1.02.
Yeah, so it's always going to be whatever that calculation for alpha divided by 2 comes out to be.
Okay,
So if you
But the-
remember in this example, we were looking at 0.025 because that was our alpha divided by 2 number.
but in this case, but with the 0.02, are we using that because of that dividing by 2 or?
Yes.
Okay, I just want to make sure I understood that.
Yeah, because once you do the 1 minus whatever your confidence interval value is, that gives you the alpha value. And then you always have to divide alpha by 2 to see where your
Okay.
Z-score is going to be.
Okay, so the alpha value is the confidence percentage.
Yes,
And
one
then, okay.
minus that, yeah.
Okay, got it.
Okay, yeah, very good. So what we're again doing is building up for this formula. So we've got our p hat, which was that 69%. We've got our error, which they told us in the example was 5%, so 0.05. You know, of course, if you know p hat, you can calculate the 1 minus p hat. So now the last part we had to calculate was this value. And this is your alpha over here. This was alpha divided by 2. And now we have the Z-score of alpha divided by 2. So now that we have all of these individual components calculated, we can now figure out what that N value is going to be. So that's going to be our next step here. And I'm just going to put N over here and do the calculation here. So again, remember N is, and let's get rid of these drawings here. So N is P hat, so that's the 0.69. And again, you are multiplying that, and I'm going to put this in parentheses again. 1 minus p hat, so that's the 0.69 again. So that takes care of the first 2 parts, and then you're again multiplying, and I'll put this in parentheses, your Z-score, which was the 2.05, divided by your error E, which is the 0.05, close parentheses, and then you are raising it, so just use the little, caret symbol. Raise it to 2. And like I said, you can use these with numbers also if you don't want to do the cell. So your p hat is 0.69 multiplied by, again, in parentheses, 1 minus 0.69 multiply by our fraction now. So the Z alpha sub 2 was 2.05. Divide that by your error of 0.05, and you're raising it to the second power. So you can see same calculation, either use the cells or use the numbers themselves. And I would imagine they're probably having us do 3 decimal places, but let's verify. Oh no, they want us to round it to the nearest integer. So not in decimals, because I guess it makes sense since we're talking about surveying people. I guess we don't really want to break them up into parts. So what do you think your rounded answer will be to the nearest integer?
360.
360, very good. So let's come back over here and see what this comes out to be. All righty, that looks good. So just to kind of show you how those same formulas are used in different ways with these 2 examples. Any questions on this one, guys? Okay, very quickly, I know we kind of took a little bit longer than I had anticipated for that first example, but I just wanted to show you in your 9.2 section. So these are also, based on confidence intervals, but here we are actually using t-distribution instead of, the Z-scores that we were doing in the previous section. So they will actually give you, you can see this is actually your sample data that you will be using. Here's the second sample. And then here is where they give you those t distribution, critical values. So this one you have to use a little bit of a different table, and you have access to this table in that formula sheet that I gave you. You will see the little t distribution table in these also. So you do have access to that. And, of course, these examples are showing you. Now, as far as your calculations go, these calculations are going to be very, very similar to what we just talked about with the 9.1 examples, but your formulas are going to be a little bit different. So you've, of course, got, your point estimate that we did, the p hat, that actually becomes the x bar over here. You do have to calculate your degrees of freedom. And this one actually is as simple as, whatever the n value is going to be, you're doing n-1 for those degrees of freedom. But look at this formula over here. This is the one which changes a little bit or quite a bit from what you have done, because I don't know if you recognize this or not, but this is your, very similar to your standard deviation formula. And then you can see how all of those numbers together help you come up with the confidence interval. So you have your X bar, which is similar to, as I said, your point estimate calculation. Instead of your Z score, we're kind of using this T value over here. So you can again see the same idea of alpha divided by 2 with that T. And then S is where this formula comes in, and then you're dividing it by your square root of n value. So a little bit of a different formulas over here, but the setup is going to be very similar. So what I'm going to do is let me share this link with you guys. So you can at least take a look at what these formulas look like, and they can help you. And you can copy them and try and work through some of the examples yourself to try and see how this will come out to be. So I'm sharing that link with you again through the Zoom chat. So just save this link, like I said, go to file and make a copy so you can save a copy of these to help you out. And so that way you can look at what the formulas are and then help you break down. And I've actually included another example. So there are 4 different examples that I was hoping we would have time to go over, but sometimes it does not work out how I want to. So look through those examples, guys. And of course, if you're stuck, you need help, don't hesitate to reach out to me, and we can go over some of these examples, maybe one-on-one or something like that if you need that additional help. So yeah, just look through these 4 different pages that I have here in your Google Sheets, and hopefully they will at least give you a starting point of where you need to break down some of these examples. So before I let you guys go, any other questions coming to mind, especially about that last example we just got done talking about? Nothing yet? And I know sometimes when you start working on your own and start going through the example, some questions may come up that you don't think of right now. So again, send me an email. And like I said, if you want to meet and go over some of the examples, we can do that also.
And can you email me that Google Sheets? Because it's not letting me open the link.
It's not letting you open it? Okay.
Mhm.
Yeah, I'll go ahead and email you the link. I'll probably do that for your entire class, even for those kids who are not here today, if they want to
Thank
look
you.
at it. But yeah, email you the Google Sheets. I am not that old, but if I don't write stuff down, sometimes I forget. So I've made it a habit of writing things down. So just in case I tell you I'll do it, but then I forget, and then, that does not look good. So yeah, I usually write everything down. So I'll send you guys the formula sheets, which hopefully all of you were able to gather that. And I'll send the link to the Google Sheets as well. Anything else, guys? Okay, so I'll go ahead and give you that extension on time because of the weekend issues with technology. And then if not, I don't see you sooner, I will see you guys next Monday. So have a wonderful week, guys. Be careful and see you on Monday.
Thank you so
Thank
much.
you.
Take care, guys. Bye-bye.
Oh, and Mr. Ruka, I
Yeah,
had a question about the final.
Yes.
'Cause I thought I read somewhere and I couldn't find it again that we have to do it in person.
So there's actually two parts to your final exam. So one of them we will be doing in class, which is the shorter version since we only have an hour's meeting. So you will be doing the first part with me on August 9th, kind of like how we meet in class right now. You'll be
Okay.
meeting for the exam. So it's not in person like you're coming to campus. We're still doing it over Zoom. And then the
Okay.
second part, the longer part of the exam is what you guys will be doing at home. So you have 2 days to complete that exam. So it will be open Monday and Tuesday of our final
Okay.
week.
Okay, so Monday, then so I have till Tuesday to finish it. Only because I have surgery on Tuesday, so I didn't know
Oh,
if am I able to open it for Sunday, Monday, at all? Do you?
let me look into it.
Okay.
And I can let you know because I would like you to have the same amount of time as your classmates. So yeah, I can possibly open it Sunday morning and give you till Monday evening, kind of like the
Okay.
same time frame, but just move
Right.
it a day earlier for you.
Right. Okay.
So for you, it would close on Monday night instead of Tuesday night.
Right.
Yeah,
Yeah,
I can do
because
that.
I have surgery at 7 in the morning, so I don't have any time that on Tuesday, I guess. So I
Okay,
didn't know how that
I
would
hope
work out.
everything is okay though.
Oh yeah, my jaw, they have to remove a disc and yeah. So
Oh.
well, yeah. And I was like, I probably might be able to do some later on that evening, but if I could move it the day earlier,
Yeah, I
that
think
would
it would be
be
better because you just don't know how much pain you will be, how much
right.
discomfort you may have. So I
Mhm.
would not want you to, be through pain and try and take an exam because
Right.
it could affect your performance on. So I think you
Right.
yourself will be comfortable just finishing it before and not
Right.
having to worry about it after surgery.
Exactly. Yeah. Okay. Sounds good. Thank
Okay,
you.
so yeah, I'll move it to
just let me
Sunday to
know.
Monday for you.
Okay.
And I'll
Sounds
email you just to let you know that I've changed the dates and everything for you.
got it. Okay. Thank you so much. I appreciate it.
Yeah, no problem. You take care, Crystal.
You too. Have a good week.
You too. Bye-bye.